Scientific notation. Scientific notation has a couple requirements. First, um, there should be only one number followed by a decimal. And that number can be 1, 2, 3, or down to 9. Okay? But basically, we're just saying that we can't have a 0 out here. So 1 through 9 is fine, just not 0. Then, after the decimals behind the very first non-zero number, followed by 10 to some power. 10, let's say 10 to the fifth power, or maybe 10 to the maybe even 0 power, maybe 10 to the negative third power. But again, some 10 to some power. And once you have this, you have scientific notation. Now, what does scientific notation do? If your exponent on the 10 is positive, it'll make the number larger. Numbers are made larger by moving to the right. If the exponent is negative, then it'll make your number smaller. We make smaller numbers by moving the decimal to the left. So let's make all these larger numbers by moving the decimal to the right 2 times. Okay, so 10 to the second power, we're going to make it larger. So this is one move, and this is now 2 moves to the right. And so the number now is 314. Now, if I move this decimal to the right twice, it'll move here. And I can't get a second movement because there's no more numbers, so what we do is add a 0 so we can get a second movement. And now the number ends up being 1340. And that's definitely larger. So we want to make this larger by moving the decimal twice. Once again, we're going to put the understood decimal here, and then keep adding zeros every time we need to move twice. So here's a 0 here that gives us the ability to move once, and I add another 0, and I can move a second time. And the number ends up being 31400, 31,400. Okay, for this one, again, the decimal is understood to be here. I'm going to move it twice to the right. So 1, add a 0, and then add another 0 to move a second time. The number that we end up getting is 314000. So 314,000. Okay, now, negative exponents. This tells us the number needs to be smaller, so we will move the decimal to the left. Okay, so this decimal needs to be moved to the left to make it smaller, twice. I can move it once here, but I'm out of numbers, so I add a 0 so I can move one more time. And so the number ends up being 0.0314. If I move this to the left twice to make it smaller because of the negative exponent, the second move ends up right in front of the 3. So this number will be 0.314. Now, once again, we need to find the decimal in order to move it twice to the left to make it smaller. There's no decimal, so we put an understood decimal here, and then we can move it. So that's one move, and then the second move puts us right there. So this will be 3.14. And lastly, again, we have no decimal, so we'll assume that it is right here. And we're going to move it twice to make it smaller. 1, 2. And this will end up being 31.4. Now the 0 after 4 doesn't hurt if you put it or not. So if you put it, it's still okay. If you don't put it, it's okay. Alright, now let's take numbers that are in scientific notation and write them in standard form. So this is 1.5, and the second power means it needs to make this number larger, or this is representing a larger number. So we're going to move it twice to the right. 1, and then add a 0, and we get 2 moves. So it ends up being 150. Okay, next one, number 2. Okay, once again, 1.5, but the negative 2 means we need to make this number smaller. So to make it smaller, I have to move to the left. So this is one move to the left. I have to add a 0 to move a second time to the left. So we end up getting 0, 0, 1, and 5. Okay. This positive one means we need to make this number larger. So we start off with 9.00 and 5. And to make it larger, we're going to move it to the right, decimal to the right one time. So it'll go right there. So now it becomes 90.05. Okay, next. We have 9.005. And this tells us that we need to make the number smaller by moving it one time to the left. So one time to the left puts the decimal right here. So now we have 0.9005. Okay, now we want to turn these into scientific notation. So what we have to do is get the decimal to go right behind the first non-zero number, which will be right here. And we have to find out how many moves that is. So the decimal is located, let me show you where the decimal is. The decimal is located right there. So in order to move it behind the first non-zero number, that's 1, 2, 3, 4 moves. So 4 moves. So this will be 1.35, again we don't need the zeros there, times 10, and the 4 moves is represented by the 4. Now, if the original number is large, that needs to be positive. If the original number was less than 1, which means it's a small number, this needs to be negative. So this will tell you whether we dealt with a large or small number, and that was a large number. So we'll make sure that that is positive 4. Okay. All right. Next, we want the decimal to go right here. So right now we have 0.013500, and to go put the decimal behind the first non-zero number, it means it goes right there. So this is going to be 1.35. Then times 10, and that was 1, 2 moves, so that's going to be a 2. Now, the original is a small number, so to represent that this was a small number, we're going to use a negative, and that tells us that the original was that this is representing a small number, or should I say a number that is less than 1.